Dear my student, good morning everybody. I am going to start my first lecture in the course Crop Production Technology. Second, I am going to deliver lecture on the crop wheat, which is actually assigned to me. I will cover around 5 crops. The first one will be the wheat, second one will be the barley, third one will be the potato and the sugarcane. As you know, wheat is one of the most important crop in the world and second most important crop in India. In world, it is actually occupy 220.19 million hectares, and in India it is next to rice crop. In India it occupies around 29.55 million hectares tons. And dear student, wheat is such a type of crop which actually ensure our food security for India. As you already know that Green Revolution in India took place in 60s and 70s. That is only due to the increase in the production of wheat. So wheat is one of the most important crop in India to ensure the food security. Now India is self-sufficient due to higher production of wheat. For the year 2018-19, India produced 101.2 million tons of wheat, and that is the year in which we actually surpassed 100 million tons of wheat production. Average, as far as the concerned productivity of the wheat in India, it is lower than the Egypt, China and other countries. However, in India, on an average, nowadays the productivity is 3 tons per hectare. Nearly 55% of the world population depends on wheat for about 20% of calorie intake. Wheat is such a type of crop which can be grown in diverse climate, and in India mainly 3 types of wheat are grown, and the type of wheats are bread wheat, that is Triticum aestivum, then durum wheat, that is Triticum durum, that is also known as macaroni wheat. Then the third one is Triticum dicoccum, and that is also commonly known as emmer wheat. Actually, in India, among the wheat, 3 types of wheat, bread wheats contributes about 95% of the total wheat production in India, and 4% contribution is from the durum wheat and 1% from the dicoccum wheat, that is emmer wheat. As far as the origin is concerned, a lot of site has been discussed, particularly for the durum wheat. The durum wheat, it has been found that its origin was in Ethiopia, and Ethiopia is in Africa, whereas the whole group of soft wheat, that is bread wheat, the origin is originated in the, most probably the origin is region of Pakistan, southwestern and southern parts of mountains in Bukhara. Nowadays it is in Uzbekistan. In India, wheat is grown in 6 agroclimatic zones, and where in the Indo-Gangetic plain zones, comprising the 2 zones, the northwestern plain zones and northeastern plain zones. And this Indo-Gangetic plain zones is actually contributes most of the wheat cultivation in India, followed by the central zone and the peninsular zone. So you can see the different area, approximate area in different 6 major zones. The first zone is northern hill zones, and it comprises the hilly areas of Jammu Kashmir, Himachal Pradesh, Uttarakhand and Sikkim. The next one is northwestern plain zone. Northwestern plain zone is one of the most important plain zones, which largely contributes the production of wheat, and in this zone the climatic and soil factor is very favorable to growing of the wheats. So the productivity of wheat in northwestern plain zone is comparatively higher than the rest of the zones. This zone comprises Punjab, Haryana, parts of Rajasthan, Trai region of Uttarakhand and western Uttar Pradesh, parts of Himachal Pradesh, parts of Jammu Kashmir and Chandigarh. It actually contributes 11.55 million hectares. So we can say that northwestern plain zone contributes the largest in area, and it contributes also in largest in production. Then the second most important zone, apart from the northwestern plain zone, is northwestern plain zone. It contributes 28 districts of the Uttar Pradesh, and most of the district concentrated in eastern Uttar Pradesh, Bihar, Jharkhand, West Bengal, Assam and Orissa, and other northeast states except Sikkim. It contributes about 10.5 million hectares. So after northwestern plateau zones. The northeastern plateau zone is the second important in area and in contribution to the wheat production. The third most important zone is the central zone. It consists of Madhya Pradesh, Gujarat, Chhattisgarh, Kota and Udaipur division of Rajasthan and Jhansi division of Uttar Pradesh. It contributes about 5.2 million hectares of the total land comes in India. Then the fourth important zone is peninsular zone. It comprises Maharashtra, Tamil Nadu, except some parts of Nilgiri and Plani Hills, Karnataka and Andhra Pradesh. And this zone contributes about 1.6 million hectare in area. Now you can see the area. You can see the production in different zones. Actually, the classification of the wheat in India has been done in 6 different zones, and the basis of classification of zones has been based on the climatic condition, soil types, growing duration of wheat, snowfall, fog and others. Then the next one is the minimum and maximum temperature, wind velocity and wind's direction, sunshine hours, etc. This needs to be considered for the cultivation of wheat in different agroclimatic zones. And this should be matched with the modern variety and matching production and protection technology that are developed specifically to mitigate the possible anticipated effect of climate change. Now, I have already told that there are 3 types of wheat that is grown in India. The first type of wheat, that is emmer wheats, and in scientific name it is also known as Triticum dicoccum, and this is grown in very little area in India, only nearly about 1% of the total area cultivated in wheat in India, and it is mostly grown in Maharashtra, Tamil Nadu, Karnataka. It is also grown in Spain, Italy, Germany and Russia. The second type of wheat, that is macaroni wheat. Macaroni wheat has its importance particularly for the commercial purpose, as from macaroni wheat we can make a lot of different type of dishes or different type of products of the wheat, like semolina or noodles and other products. So durum or macaroni wheat cultivation in India is considered to be very old, and it is actually cultivated in rain-fed areas where there is a little irrigation, and its cultivation is restricted only some parts of the Punjab, Madhya Pradesh, Karnataka, Tamil Nadu, Gujarat, West Bengal and Himachal Pradesh. It is largely used for the semolina, that is also known as the suji, and its contribution in Indian wheat production is in as far as area is concerned is only 4%. And the most common wheat which is grown in India in more than 95% of the total area is common bred wheat, and in scientific it is also known as Triticum vulgare. It is a typical wheat of alluvial soils of Indo-Gangetic plains, which is grown largely in Punjab, Uttar Pradesh, Bihar and West Bengal. The bulk of the Indian crop therefore consists of this type of wheat. Now the fourth one is Indian dwarf wheat, that is Triticum asphaerococcum, and it has very limited area, so we can say that above 3 we actually cultivate in India, and the Indian dwarf wheat, that is Triticum asphaerococcum, area is very less. This is found in limited areas of Madhya Pradesh, Uttar Pradesh of India and in some parts of Pakistan. These are characterized by the very short and compact head having a shorter grain. Now presently in India we are growing the wheat which is known as generally Triticum aestivum, which has been developed by hybridization with the Indian bred wheat with the Mexican wheat, and this is the type presently grown in India in almost all the wheat growing zones. It is mainly used for the chapatis, biscuits and bread purpose. Now the climatic requirement. The climatic requirement of the wheat is one of the most important factor. Actually, what is the temperature of particular area? What is the duration of winter in particular area? What is the rainfall of particular area? What is the type of soil of the particular area? What is the irrigation possibilities? And these are the factors which actually determine which determine the actually production of the wheat. Although wheat has wide adaptability, it can be grown not only in the tropical and subtropical but also in the temperate zone like in Europe or Russia or in China. Wheat can tolerate severe cold and snow and resume growth with the end of the severe cold or coming of the spring. It can be cultivated from sea level to as much as high of 3,300 meters. Apart from that, but the best wheat are produced in the area which has cool, moist weather during the major portion of the growing period, followed by dry, warm weather to enable the grain to ripen properly. The optimum temperature range for the ideal germination. Actually, question arises when we should sow the seeds of the wheat. What will be the ideal temperature? What will be the optimum temperature when we should sow the seeds? So the optimum temperature for Ideal germination of wheat seed is 20 to 25 degrees Celsius. When the mean temperature ranges in between 20 to 25 degrees Celsius, then we should sow the seeds. All the seeds can be germinated from 3.5 degrees Celsius to 35 degrees Celsius. Actually, a rain just after sowing of the seeds hamper the germination of the wheat seeds. The area with a warm and damp climate are not suited for the growing of wheats. During the heading and flowering stage, excessive high or low temperature and drought are very harmful to wheat crop. Cloudy weather with high humidity and low temperature is very conducive for the rust attack. As we know, there are three types of rust which attack the wheat crop. The first one is black rust, second one is yellow rust, and third one is brown rust. So if the temperature is low and coincide with the high humidity, then the chances of infection of these rust disease is very high. So temperature for the sowing is, average temperature for the sowing is 20 to 25 degrees Celsius. The temperature for tilling will be 16 to 20 degrees Celsius. The temperature for the ripening should not be exceed to 25 degrees Celsius, and 22 to 25 degrees Celsius is very conducive for the ripening of the wheat. Above than 25 degrees Celsius, average mean 25 degrees Celsius is very depressing for grain growth. When temperatures are too high, too much energy lost through the process of transpiration by the plants, and that reduce the actually total yield. So temperature never be high more than 25 degrees Celsius. As in India, wheat is mainly grown in the winter and that matures in spring season. So in India we actually call wheat as a spring crop, and it is grown in RABI and we harvest in spring season. But unlike in India, in China or most part of the Europe and Russia, it is grown as in temperate climate. Next, the climate. The ideal temperature requires, as we have already told that, for the different stages, the temperature requirement of the wheat is different. For the germination, 20 to 25 degrees Celsius. For the tilling, 16 to 20 degrees Celsius. For accelerated growth, 20 to 23 degrees Celsius mean temperature. And for proper filling of the grains, that is 23 to 25 degrees Celsius. as you know, wheat plants are very sensitive to very cold and frost injury at any stage of crop growth, particularly at the time of reproductive growth if the temperature goes down to 50 degrees Celsius. No, now what we should do for the land preparation? So actually wheat crops required well pulverized soil, but that should be compact seed bed for good and uniform germination. As one of the proverb is ढेले चना and मैदे गेहूं. That means for the cultivation of wheat, you have to make soil well pulverized like powder, like maida. But same situation if you grow to any chickpea or chana, then there should be clouds, there should be no well pulverized. So the ideal situation for the wheat crops is well pulverized soil. For that purpose, we have to do 3 to 4 ploughing in the summer, repeated harrowing in the rainy season, followed by 3 to 4 cultivation and planting immediately before sowing to produce a good and firm seed bed for the dry crop on the alluvial soils. For the irrigated crops, the land is given a pre-sowing irrigation. Pre-sowing irrigation means before sowing, the irrigation is given for the preparation of the land. So after the preparation of the land, it is better to apply 25 kg chloropyrifos per hectare after the last ploughing and before planting, so that if there is any infestation of termite, then by applying the chloropyrifos, we can reduce the infestation of termites in coming time. Now the sowing time, based on the temperature requirement, it has been found that for the indigenous wheat crop, that is Triticum vulgare, last week of October is the best time for the sowing of wheat. For long duration dwarf variety, which is nowadays after green revolution is nowadays grown, just after during the green revolution to nowadays, the best time for the sowing of the dwarf wheat variety like HD2967, DBW187 and other varieties is the first fortnight of the November. And for the short duration dwarf wheat variety like Sonalika, Raj, 821, NW2036, DBW14, WR544, etc. should be grown in the second fortnight is the best sowing time. So we can say that nowadays for the irrigated condition timely sown, the wheat should be grown particularly in the Jharkhand or in Bihar in the first fortnight of the November. Now due to the climate change, the temperature nowadays is for the wheat, for the growing of wheat, now at optimum temperature is nowadays coming in the first week of November. So first week of November we can sow the wheat for the timely sowing in irrigated condition, and for the late sown condition, last first week of December is most suitable time. So the first week of November is the most suitable time for the growing of timely irrigated wheat, and particularly in the rice wheat system, as the field is, as the rice crop is not harvested or harvested in the late, particularly in the November or December, so the field is not vacant, then for the late sowing of the wheat we can go up to first week of December. Now the seed rate. Seed rate is one of the important factor which actually determine the plant population. As you know, the plant population is one of the most important factor which determine the grain yield. If the plant population is less, you will obtain less yield. So for proper plant population, seed rate is very necessary. So what will be the optimum seed rate? So seed rate varied if the seed size is small, the seed rate will be less. If the seed size is bold, then seed rate will be high. A seed rate of 100 kg has been found to be sufficient for the most of the dwarf variety like HD2967, K9107, K307, DBW187. So for the timely sowing condition, 100 kg seed is sufficient for most of the dwarf varieties of wheat. But higher seed rate of 125 kg per hectare is desirable for the late sown condition. If we go for the growth of the wheat in late sown condition, particularly first week of December, then we have to increase at least 25% of the total seeds. So in that condition, the requirement of the seed will be 125 kg per hectare. And this is also true for the bold seeded wheat variety like Sonalika, Raj, HI 1544, GVW 496, then LEC1. All these varieties have bold grains as well as sciential ring. Now the other important agronomical practices is the spacing. Spacing also determine the plant population as well as seed rate. If the row to row distance is less, then the seed rate will be higher. So for the proper plant population, spacing is one of the most important factor which determine what will be the seed rate, what will be the optimum seed rate. So for the timely sowing condition, the distance between row to row in the wheat is 22.5 centimeter if you grow in timely sown condition, that is in the first week of November. And if you want to grow in late sown condition, that is first week of December, then you have to decrease the spacing, and the spacing will be 20 centimeter row to row. Here we do not maintain the distance between plant to plant. Now the other aspect is depth of sowing is very important aspect in successful cultivation of high yielding of dwarf variety. Friends, as you know that the gene has been a dwarfing gene, that is not in 10 gene has been incorporated in Mexican wheat, and Mexican wheat hybridized with the Indian traditional wheat, which resulted in the shortening of the heights of the wheat plants. So generally high yielding dwarf varieties have the length of cleotile is very less. So the cleotile length of high yielding Mexican dwarf variety is about 5 cm. Therefore seed of this variety should be covered not more than 5 cm. So for the dwarf variety, depth should not be more than 5 cm. That most optimum depth is 2 to 3 cm. Whereas in the case of traditional wheat, Indian wheat, take for example C306, the depth may be up to 7 cm. Seeds of semi-dwarf, that is one gene dwarf variety, could be sown at the depth of 5 to 6 cm. Seeds of 3 dwarf variety should not be sown deeper than 4 cm. Similarly, in the late sown crop, seed should be sown in shallow, as deep sowing delay the emergence of the seedling by 2 to 3 days and heading 5 to 6 days. So by decreasing the depth of sowing, we can advance the maturity days. This is all about the zone wise agronomical technology. The first zone is northern hill zones, and the sowing time is 1 to means first week of first November to 15th of November. The seed rate will be 100 kg, fertilizer 120, 60 and 40 kg NPK per hectare, in which the 1/3 of total nitrogen and full dose of P and K will be given as a basal, and remaining nitrogen in 2 equal splits, that is in first irrigation, and the second dose will be given at the second irrigation. So the nitrogen 1/3 will be given in basal, and rest of the 2/3 nitrogen will be given in 2 equal doses in first irrigation and second irrigation. In northern hill zones, for irrigated late sun condition, it should be grown. The sowing date is 25th of November. The seed rate will be 125 kg. But here the fertilizer dose will be decreased. Here the fertilizer dose will be 90, 60 and 40 kg NPK per hectare. 1/3 of nitrogen and full dose of PK will be applied as a basal dose, and remaining nitrogen in 2 equal splits dose at first and second irrigation. Then comes to the second zone, that is northwestern plain zone and northeastern plain zone, and this is the most important. These are the most important zones. In northwestern plain zone, for the irrigated timely sown condition, the wheat crops should be grown in between 1st to 15th of November. The seed rate will be 100 kg. And nowadays the fertilizer dose has been increased up to 150 kg, 60 kg and 40 kg in place of 120 kg. So nowadays 150 kg nitrogen is recommended for getting higher yield. So 1/3 of the nitrogen and full dose of phosphorus and potash will be applied as a basal dose, and remaining nitrogen will be applied in 2 split doses at first and second irrigation. As you know, first irrigation will be given at CRI stage during 20 to 25 days after sowing, and the second irrigation will be given 40 to 45 days after sowing. Then for the irrigated timely sown condition for the north-eastern plain zone, where as we have already told that nowadays due to climate change, the optimum temperature has found for the proper growth of the wheat is first week of November. So we can start sowing of the wheat first week of November. First week of November, the seed rate will be 100 kg, and the fertilizer dose is same as 150 kg nitrogen, 60 kg phosphorus and 40 kg potash. And the nitrogen, 1/3 of the nitrogen will be given, 1/3 of nitrogen, full dose of phosphorus and potash will be given at the time of sowing as a basal dose, and rest of the nitrogen will be given in at first and second irrigation. For irrigated late sown condition, that is after 25th November or first week of December, the seed rate will be enhanced, that will be the 125 kg per hectare, and the fertilizer dose will be 120, 60 and 40 kg. Now comes to for rain-fed wheat. For the rain-fed wheat, the optimum timing of the sowing is last week of October. The seed rate will be 125 kg, 125 kg, and the fertilizer dose will be 60, 30 and 20 kg, and all fertilizer, nitrogen, phosphorus and potash will be applied during the sowing as a basal dose. There will be no any split dose or top dressing in rain-fed situation. Now the central and plateau zone, you can see from this table that the irrigated timely sown condition in central zone, that is 10th to 15th of November, plateau zone that is 1st to 15th of November, then southern hill zone that is mid-November, irrigated late sown condition, central zone, southern hill zone, first to 15th of December, the seed rate is 125 kg, the central zone, plateau zone, the fertilizer requirement is 120 kg, 60 kg and 40 kg per hectare. 1/3 of the nitrogen and full dose of the phosphorus and potash will be applied as a basal dose during the sowing, and rest of the nitrogen, that is 2/3 of nitrogen, will be applied in the split dose at first and second irrigation. And all for the rain-fed situation, 125 kg seed rate, 60, 30 and 20 kg NPK to be applied during at that time of sowing. Now the soil. Wheat is grown in the variety of soil, but most suitable type of the soils of India is clay loam or loam texture soil. A good texture and moderate water holding capacity are ideal for wheat cultivation. Care should be taken to avoid very porous and successive drained soils. Soil should be neutral in reaction. Heavy soil with poor drainage, poor structure and poor drainage are not suitable for the growing of the wheat. Wheat can be successfully grown on lighter soil provided their water and nutrient holding capacity are improved. Now after the soil, the next is fertilizer management. Time and placement of fertilizer is another important area where significant progress was made. Earlier it was found that the 120 kg nitrogen, 60 kg phosphorus and 40 kg potash per hectare were required for optimum productivity. The nitrogen was to be applied in two split dose of 60 kg as a basal and the remaining 60 kg at first irrigation, and full phosphorus and potash to be applied as a basal. But nowadays, recently, the new wheat variety have responded to 150 to 180 kg of nitrogen per hectare. So nowadays 150 kg nitrogen is recommended for the growing of the timely soil irrigated condition, and particularly in the Indo-Gangetic plain zones where there is a calcareous soil and the pH is very high. Generally the deficiency of zinc has been found in that type of soils where actually very popular rice wheat system. So in that condition, if there is a zinc deficiency, then zinc sulfate zinc at the rate of 25 kg per hectare should be used during sowing of the crops. At national level, all the nitrogen, phosphorus, potash, zinc and sulfur deficiency has been found in many parts of the India, but nowadays at the national level the deficiency of micronutrient has been found, and most of the wheat growing soils in India, 46% is deficient in zinc, 17% is deficient in boron, 12% is deficient in molybdenum, 11% is deficient in iron, 5% deficient in copper, and the deficiency of sulfur has also been reported across a wide range of soil, that is 38% of the total Indian soil. So the yield response to the sulfur has been obtained in more than 40 crops, particularly including cereals, millets, oilseed and pulses. To realize the potential yield, a strategy may include what strategy we should take to get the maximum yield. The first is site specific nutrient management for targeted yield, integration of crop residues. As you know, the crop residue is the remaining parts of the plant after harvesting of the grain part. So if we incorporate the residue in the soil, that resulted in the increase in the nitrogen, phosphorus and potash nutrient in the soil. So we should try to incorporate as much as possible of the residue of the crops, so that there will be less mining of the nutrient from the soil. The next one is integration of crop residue by fertilizer. Nowadays it has been advocated that less use of the nutrient, as we have found that due to in green revolution, due to excess use of chemical fertilizer, nowadays even 200 kg nitrogen does not give significant response in the increasing yield. So nowadays we are advocating that we have to add as much as possible biofertilizer as well as farmer manure and vermicompost and other organic matter. So at least we should add 30% nitrogen source from the organic, and that source may be from the biofertilizer, that source may be from the farmer manures, that source may be the crop residue, that source may be the vermicompost. So we must integrate the nutrient management in the wheat, inorganic as well as organic source. 30% from the organic source and rest 70% from the inorganic source, so that the soil health will be maintained. Now the different techniques how we can increase the yield as well as increasing nutrient efficiency, tillage technique like FARS. Then other is remote sensing for efficient nutrient management. Nowadays we are using the remote sensing for the nutrient management, particularly for the differential fertilizer applicator. Then nutrient management, straw, adding of the straw in the soil. We have already discussed about the deficiency of the micronutrients. If there is deficiency of the zinc, then we should apply the 25 kg of the zinc sulfate per hectare. That will be once in a year, and 10 kg to each crop during Rabi and Kharif season should be applied there where it is deficiency prevalent. And if there is any deficiency in the manganese, particularly manganese deficiency has been found in the some parts of the Punjab, Haryana and Western UP. So in that case, spray 0.5% solution of manganese sulfate, dissolve 2.5 kg manganese sulfate in 500 liters of water. First spray should be done 2 to 5 days before irrigation, and remaining 2 to 3 spray at 1 week and interval. And spray should be done during clear and bright sunny day. In case of sulfur deficiency, soil application of sulfur or spray application can be resorted for correcting deficiency. When zinc sulfate or gypsum is resident in the soil, then there is no need of giving extra sulfur from other source. Actually, zinc sulfate and gypsum take care the deficiency of the sulfur. So these are the strategies may help in reversing the adverse effect of the soil. Nowadays the soil health is going down. So adoption research conservation technology like zero tillage, conservation agriculture, minimum soil disturbance to conserve soil, residue management, incorporation or surface residue retention to enhance the soil organic matter. Next strategy may be developing new and improving the available machinery for residues. Introduction of leguminous crop like mung bean to regain and build up the soil health. Green manure to increase soil organic matter, and balanced use of NPK in proportion along with the FIM, and need-based application of zinc, manganese, iron, copper, molybdenum and boron as a micronutrient for optimum yields. So my dear student, आप लोगों को जो भी हमने आज बताया उसमें से वेट का सिनेरियो ऑल ओवर भारत में, व्हाट इज द सिनेरियोस इन इंडिया, व्हाट इज द ओरिजिन ऑफ द वेट्स, व्हाट इज द क्लाइमेटिक कंडीशन ऑफ वेट, which type of soil is suitable for the wheat, different types of wheat, different type of land preparation, nutrient management and other practices. So I want to end this chapter, I want to end the lecture today, and next lecture I will deliver on the wheat itself, and that will be the weed management, irrigation management, plant protection measurement, and post harvest technology. All will be covered in next lecture. So please wait for the next lecture. Thank you for all my dear students and listeners. Have a good day.